And we're live. Good evening. My name is Kent Quirk. I'm here solving Advent of Code problems, and I just noticed that my title screen says day 1 is still. I keep forgetting to change that part of it every day, like I should. Anyway, it's day 6 of Advent of Code, and my dog needs attention, so I'm just going to step away for 1 second. There you go. Have fun. And he'll probably bark at some point during this thing as well. So, apologies for any disturbance. So yes, I'm solving Advent of Code. It's day 6, and without further ado, let's talk about what it is we're going to do. So first, Advent of Code puzzles, I'm solving them in Go, typically. I might, as the season goes on, play with some other languages, especially if I do this in cooperation with another person, which I might. But for tonight, we're going to do this in Go. And I am employed by Honeycomb, sponsored by Honeycomb, and if you notice, Honeycomb is a sponsor of Advent of Code. It's right here on the screen. We are going to look and see what number 6 is going to do. And this is the first I've looked at it, and there's my dog. Sorry. All right, the seafloor is getting steeper. Maybe this lake he's got carried this way. Sorry. A school of glowing lanternfish swims past. Maybe they're growing exponentially. I'm going to model their growth rate. Oh, this sounds fun. Surely each lanternfish creates a new lanternfish every 7 days. We have to randomly distribute the number of days until it creates a new one. Or maybe not randomly, but 2 more days for its first cycle. And we're doing probably a queuing simulation, or just spawn. Your puzzle input is 341, 312. I'm gonna so we're maintaining a number of fish, each of which has a different state, and then we have to count the number of total lanternfish. And just for fun, let's look at the puzzle input. It's pretty big. Figure out how big in a minute, but the question is, so clearly we have to simulate these things, and each simulation does it. Now, an easy way to do this would be to create a fish object, and a single fish would be simulated. But the thing about this is that this thing's going to grow exponentially, and we're going to end up with a huge number of such things in memory. So if we were to do it as individual fish, we might find ourselves running out of memory. But the thing about this that's interesting, and we've got 80 days to deal with, and we're going to have 6, even with 5 fish to start with, we're going to have 5,000 after 80 days. So if we start with a couple hundred fish, we're going to have a couple 100,000 lanternfish after 80 days. Instead of simulating each fish individually, I mean, the thing about it is that the fish are not unique. initially each fish has a different number of days, but a given each day, a 0 becomes a 6 and adds a new 8 to the end of the list. Well, each other number decreases by 1 if it was present at the start of the day. So what I'm wondering is if we can, if each instance of a fish, if we can just keep a counter of how many there are just like it, so that we can say, okay, well, there are, 10 fish in state 0 and 23 fish in state 1. And then adding up the total number of fish is just counting the number of fish in each individual state. And the only problem is just making sure that we keep our states separated. Appropriately. So, so let's do this. All right, I'm going to switch to my editor. And I am going to go to my input and paste in the sample data. Save that, and then I'm going to post in the real data for the real input. And just for fun, that is column 600, and there were 2 per column, so it's 300 fish in our starting population for real. So we're gonna want to count the number in each state rather than propagating each individual fish. So let's do go, and before we even parse this thing, let's create a type of a I'm going to call it a fish state rather than a fish, because each individual fish doesn't matter, only the state of all the ones that are the same value. So a fish state has a timer, which is an int, and a count, which is an int. And we're going to do a function called tick. It's on a fish pointer, fish state. Tick function. And when we call tick, we are going to pass it our ocean, which is going to be, well, hold on a second. Let's think about this. All right. So we say, so for a given fish state, we have a timer. We want to decrement the timer. So we say f.timer gets decremented. And then or maybe, no, let's say this. If f.timer is 0, according to the rules in the web page, it says after another day, its timer would become 0. And then the day after that, after another day, its internal timer will reset to 6. And then it will create new lanternfish with an internal timer of 8. So f dot timer equals 6. But we also have to create else. We have to spawn new fish. So f dot timer is 6, and then we're going to say we're going to maintain a list of the timer of the fish groupings of a given category or given time. So that grouping I think what we will do is create a if we have a slice of fish state, we'll index by their timer value. This might be easier. Might not, maybe rather than doing a fish state, we should just literally maintain a map of timer value and count. Whew, it could be a lot faster. Instead of doing this as a tick function, and then we just iterate through that map, and then we just create new entries in the map. I'm just going to comment these out for a bit until I decide that I'm doing it wrong. But let's just say the ocean excuse me. Sorry, I'm staring at this because I'm just thinking about parsing it. We want to get a bunch of integers out of a single line. So we can open input sample.txt and instead of lines, we can just do s is strings dot trim of string b. Oh, sorry. And white space, new line, tab, just in case there's any of that stuff in there. We're just going to trim those off the ends. And then numbers is split strings dot, or sorry, split s by comma, and then for n colon equals range nums we're going to just say states is append states, comma, so they're all single digit, they're all integers. And so I'm just going to do a trick here, which is I'm going to take states, or n, the 0 character in n, and subtract 0 from it, and that's going to return a that is value of type byte, and so I'm just going to call that an int, or I mean convert it to an int. I'm just going to run this and print it just to make sure that I didn't screw it up. So terminal (34312), 34312 are my initial states. So lovely. Okay, great. So now I've parsed my states. I have a slice containing all of them. And then I can say ocean is make map int. So for s in the range of states, we're going to add them to the ocean. So we're going to say ocean is now an empty map. So when I index into it, it will give me back the 0 value of the int, which is 0. So I can just say ocean s plus equals, or plus plus. So we just index that. So now we've shoved everything into the ocean, and we have a count of how many fish are in each of the state. So I can do format.println ocean, just to make sure that that worked, and we should see one in state 2, 2 in state 3, 1 in state 4. Okay, so that's great. The ocean is correct. And now what I need to do is just iterate over the whole thing. Num generations equal 80, or it's number of days. It's not number of generations. For I is 0, I less than num days, I plus plus. Forgot my colons. If now we're going to do another loop for timer count is range ocean. if timer is 0, if I range over ocean, so here's my problem. I would like to walk through this list. If I range over ocean like that, these are going to occur in random order. But what happens is when I get to 0, I want to increment the value in 6. And the problem is that if I ended up doing 6, then I would do it too early. So instead of doing this timer count range of ocean thing, what it should do is the maximum value is 8. So I can just do for days to 0. And now I can say count is ocean days. Oh, and actually I just said that I want to do this backwards. So I'm going to start with 8. Days, while days is greater than or equal to 0. Days minus minus. So and if count is 0, continue. Because I don't have to do anything else if the count of that number of days is, if there's nothing in it, we can just continue. Otherwise, if days is 0, now I can comfortably update ocean. So I can say ocean of 6 plus equals count. So there are now that many more fish as we had in 0. And ocean 8 there shouldn't be any okay, so I gotta so if day is not equal to 0, no, I need to move everybody down 1 unit at the end of this loop. So if days equals 0, nope. Yeah, I think what I need to do is I'm going to do this as just 7 and 9, and then after this loop, I'm going to go forward. I'm going to go forward 4 days, 0 days less than 9. And then I'm going to say ocean days equal ocean days plus 1. So I'm going to move everybody down 1. 9 doesn't get added count to it because it gets count. All right. So then when we're all done, we're going to print the score for and this is not inside the days. Oh, no, that's correct. That is correct. Now, then outside the loop, total 0. And then we say total plus equals function of days Wait. There we go. Okay. And all right. So now I have a I'm going to run this, and I'm going to set end days instead of 80. We were given sample data after 18 days, which they said should be 26 fish after 18 days. So let's just look at that much. And it's 32, and I printed a percent because, but why did I print a percent? Oh, that's just my prompt. No, it isn't. Oh, I didn't save it, that's why. All right, so I'm still wrong. But just going to try printing out the states of all our oceans. So after the first day, two, one, and none of the others. Now this one, 1, 2, 1, 0, 0, 6. So 6 now has 1. 8 and 9 both have 1. Oh no, it's okay for 9 to have 1 because it just keeps getting overwritten. So we should have 1, 2, 1, 6, 7, 8. So we have 1, 2 1s, 1 0, 1 2, 1 6, and 1 8. That's correct. Then we get 2 8s. We get 4 8s. Oh, So in that last day, we had 3 zeros. And 1, 2, 3, 4, 5 ones. 3 zeros, 5 ones. 3 twos. So are we adding? All right, let's see what happens if we change that to 80 days. Oh, but maybe we don't need to print everything in the middle of our ocean. Nope, we didn't get the right answer. Oh. I'm just going to put that in there to see if I've missed something. No, that's not correct either. I'm being a little random. All right, what am I doing wrong here? Because this certainly looks correct based on the sample data we were given. So after 18 days, I'm going to uncomment this again and run it again. Oh, that was silly of me. Go back to 18. All right. So it thinks there are 2 7s. But my sample data only has 1 7. After 11 days, I have 1 7. After 12 days, I have 3 7s. 2 8s. Next time I have 2 7s and 2 8s. Oh. But wait a minute. 14 days. I should have no zeros. All right, so how did that happen here? 12 days, I should have no 2s. I have no 2s. 13 days. Wait, sorry, no, here we go. Oh, is it something I'm doing silly? I'm just going to do this, put it in here instead. Okay, so I'm going one too many days. If I were to go 1 day minus 1, oh, because the numbering days are starting at 1. So let's do this again. After 1 day. So 17 days has well, first of all, it should be less than or equal to 9 days. And now I'm going to get 32 again. And this needs to be 8. And now, if I were to change that number back to 80, will I get the right answer this time? No, I won't. 59, 34. Boy, this isn't good. Okay, I'm doing something wrong here. I'm going to just check and see if anybody's talking at me. Oh dear. Okay, the stream is going. I was afraid the stream had died. Okay. All right, let's check and see if the number for 6 is correct. The very beginning here. because that's one thing that we're doing. So after 5 days, there are no 6s. After 1 day, I mean. After 2 days, there's 1 6. After 3 days, there's 1 6. After 4 days, there are 3 6s. After 4 days, there are 3 6s and 2 8s. After 4 days, 5 days, there should be no 0s, no 1s, no 2s. 1 3, 1 4, 3 5s, 2 6s, 2 6s, yep, 2 7s, 1 8. Ocean is a map. I'm just going to set that. Five, 1 day 5, 2 days 5, 3 days 6. So let's just see, 10 days I should have 11 fish. 10 days, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 9 days, 10 fish. 6 days, 10 fish. 5 days, 9 fish. So 5 days, 3, 6, 9, 10. 5 days in, 10 fish. In the demo. 4 days, 7 fish. So that's good. Wait, 79. 3 days. Wait, what did I do wrong here? Hold on. 3 days I should have 6 fish. No. Oh, I should add a second fish. So why is the total wrong here? Hold on. I added... This has to be 9. So my total was calculated wrong here. That was silly of me. Alright, so let's do that again. 59.34. That's the right answer. Jeez. Okay, that was bad. I got a couple of off by 1 bugs stacked on top of each other. Finally, we solved day 1. We're done. Okay. Sorry about that. Took a long time. Do something silly. I am going to comment out these lines because they don't matter. I'm going to run it again, and that's fine. So now we can do it on input rather than input sample, and run it again. 356, 190 fish. So now let's put that into the browser. That is the right answer. Yay. Okay, now we can go into part 2. Suppose. Okay, I think we did this right. We just have to set the number. So let's do input sample. And we're going to do 256 days. And run it and see if we get 269 ending with 539. We get the right answer there. So now instead of input sample, let's just do input. Now this may get big enough that we actually blow out an integer, which will be entertaining. But it's a 64-bit integer, and that's a pretty big number, and so let's see if that's gonna work. I didn't show me running it, but to be honest, all I did was change the number to 256. So that's the big number we got back, and that is correct. The best kind of correct. Yeah, we're done. Love it when version 1 works for version 2. I mean, the first half works for the second half. That, I'm glad we did that. I'm just going to delete this stuff because it turned out we never used it. And I will check this stuff in GitHub as I always do. Come find me on Kent Quirk. On Kent Quirk on all the major media, well, Twitter, and GitHub, the ones that matter, I guess. Feel free to come by and see me. Otherwise, come back tomorrow. There we go. All done.